Okay, today's lesson is lesson number 79. We're going to be continuing to talk about hyperbolas, specifically writing equations for hyperbolas. So we're going to focus on the standard form and finding the missing pieces of what we need. So here are the steps. First thing we're going to want to do is identify the center. So they're not going to give us this. We have to find out what the center is so that we have h and k. And then we want to know what the major axis is. This is important because it tells us if x goes first or if the y part goes first. Okay, and then we want to try to identify A, B, and C, see whatever they give us, and then whichever we still need, we can solve for using this equation. And once we have everything we need, we can input those values into one of these standard form equations. Okay? So for number one, the first thing we're going to do is try to just get a rough sketch of the scenario here. So the second part, the conjugate axis, what that is talking about is back when we have our little box, right, when we're graphing these, say the hyperbolas end up being on the right and left, like up here, then the points that are included, we call those the vertices. So the endpoints, you know how we graph the center, we go to the right and left, and then we go up and down. The ones that have the curves attached to them, those we call the vertices, and then the other 2 points we call the endpoints of the conjugate axis. So that would be like this, and this would be the endpoints of the conjugate axis here. Okay? Alright, so just kind of doing a rough sketch here. If negative 10, comma 1 is here, then negative 10, comma negative 19 is about here. And somewhere over here, but right in the middle of these two and out to the right, I would have 1 point, that's going to be 1, negative 9. And then out to the left, I have negative 21, negative 9. Okay, the top and bottom ones are my vertices, so I know that's where the hyperbolas are, or the hyperbola is, right, on top and bottom. And then the other two would be the endpoints of my conjugate axis. So this point right here in the middle is the center. It's going to be directly in between the vertices and directly in between the endpoints. So I know it's going to have the same x-coordinate then, right? It's in line with these points, so it's got to have this as the x-coordinate. So it would be negative 10. And then same thing with these points. It's in line here with the endpoint, so it's going to have negative 9 as the y-coordinate. Okay, so I have my center, I have h and k. I could also find b and a here, right? B is just the vertical distance, so between the center and, in this case, it's a vertex there. I see I go from negative 10, comma negative 9 to negative 10, 1. So I go up from negative 9 to 1. I know that's 10 units in between there, so B is going to be 10. Okay, and then for A, I'm going from negative 21 to negative 10 on the x, so I'm going up 11 units, so that distance is 11. And now I have A, I have B, I have H and K, so I have everything that I need to write the standard form equation. The only thing I need to know now is which part to put first. And since it said that these points were the vertices, I know that the hyperbola looks like this. So that means my y-axis is the major axis, so y will go first. So my equation is going to look like this. Okay, and that's because my center is negative 10, negative 9. So negative 10 here for h makes this x plus 10. Negative 9 for k turns this into y plus 9. B is 10, so b squared is 100. That goes with the y value, remember. And then a is 11, so a squared is 121. Okay. And number 2 here, now instead of the endpoints, we're given the foci. Remember, if I have a hyperbola like this, the foci are going to be inside the curve, right? If I have a hyperbola like this, they're going to be inside the curve, okay? So the vertices and the foci are all going to be in a line. Okay, and then same thing would happen here. They'd be in a line this way. Alright, so let's sketch this situation. If I have 3, 14, maybe that's about here. 3, negative 2 would be down here. and then the center is going to be right between them. I know my center is it's on the same line, so it has to have the same x coordinate, so it's going to be 3 there. And then I want to be directly in between 14 and -2, so I would add these and get 12, and then divide by 2 to get 6. Okay, just finding the midpoint between those two. And then if these, I could calculate this 8√2 part for the foci, but I know, again, that if my hyperbola looks like this, right, these are the vertices, so it's going to be on top and bottom. That means the focus points are inside, so they're roughly there. Okay, this top one is this right here, and then the bottom one would be 3,6 minus 8√2. Okay, if I look at these points, it says you stay at x, or stay at 3 on the x, and then in the y direction, one of them is 6 plus 8√2, and the other is 6 minus 8√2. So they both kind of start at this point, and then one goes up 8√2, and one goes down 8√2. Okay, so the C, this is just our distance C here, right? The distance between the center and the foci must be 8√2. Okay, and then this shorter distance from the center to a vertex, it's in the vertical direction, so that's going to be B. And this I can calculate, it's just the distance between 3,6 and 3,14. So I know it goes up 8 units to get there, so B is just going to be 8. Okay, then I have my center, I've got B. I need A, though, in order to write my standard form equation. So I need to find that. I can, though, it's not too difficult for me to find A. I just need to use the formula that we talked about yesterday for finding the foci. So it's going to be A squared plus B squared equals C squared. And I just plug in what I already know. Okay, I know that B is 8, so B squared is 64. And C is 8√2, so it's going to be 8√2 squared. Okay, when I square this, I bring the exponent into each term, so this is 8 squared √2 squared. Okay, so I'm going to get A squared plus 64 equals 64 times 2. Okay, 8 squared is 64, square root of 2 squared, they cancel out and I get 2. Okay, so I have A squared plus 64 equals 128. And then I subtract 64 from both sides to get A squared equals 64. Okay, now that I have A and B and the center, I can write my standard form equation. The hyperbola is on top and bottom, so I'm going to write y first. So I'll have y minus 6. Here, let me erase this. I'll have y minus 6 squared over 64 minus x minus 3 squared over 64 equals 1. Okay, and that's my final answer here. The 3 and the 6 here, 3 and 6 again come from the center point, h comma k. And then 64, this is just a squared, which we solve, with y, this is the one with y, so this is actually b squared. B is 8, so b squared is 64. And then the one with x is a squared, which we just solved for. Okay, they happen to be the same denominator, which in a hyperbola doesn't really matter. It just means that we have a square instead of a rectangle when we make this box thing. Okay, but if it was a plus sign in the middle here, it would actually be a circle then, because we could multiply by 64, and it would be a circle with 3, 6 as the center. So just keep that in mind, right? We should be thinking circle if we see the same denominator, but unless it's minus sign. Okay, so moving on now, here's 3 and 4. 3 is very similar to 1. Okay, so I plot these points. Again, this sketch doesn't have to be exact, so don't be too intimidated by the fractions here. you know you're going to have a center, and then if they give you the vertices and the endpoints, you basically make like a T here, okay? It's going up and down, and you know it's going right and left. So you just need to fill in the appropriate, give each point an appropriate label, okay? So even if it's not exactly to scale, it's okay. The center point here, though, I know it has to be in line with these, so it's going to have the same x. Okay, so the x coordinate here is going to be -7/2, and then it's going to be in line with these as well, so it's going to have the same y coordinate as those, so the y is 3. Okay, now I'm looking for these distances. I know B is going to be here and A is here. Again, B is the vertical distance from the center to one of our points, and then A is the horizontal distance. I can calculate these by just looking at how many spaces I've moved. So from -7/2, 3 to -7/2, 13. The x stays the same, but my y increased by 10. So B is 10. Okay, that's how many units are in between. And then A, I'm moving over from -7/2 to 9/2. And I could figure out that there's 8 units in between that by looking at 9/2 minus a -7/2, which will actually make it plus 7/2. Okay, that gives me how the distance in between, right? Just like if I were trying to find the distance between -1 and 3, I could do 3 minus -1 or 3 plus 1, which equals 4. So I know there's 4 units in between here. Okay. So 9/2 plus 7/2 gives me 16/2, which is just 8. Okay, and the hyperbola told me that these are the vertices. Right up here, it told me these are the vertices, so my hyperbola is going up and down. Okay, that tells me that my formula is going to start with y, or the standard form equation, excuse me, is going to start with y, so I have y minus the y coordinate, which is 3, so y minus 3 squared all over b squared. B is 10, so b squared is 100. And then the x goes next, and -7/2, x minus a negative is going to turn into x plus 7/2 squared over 64, because we got 8 here for A, and that'll equal 1. Alright, so again, that was very similar to number 1. Number 4 here, we're given the vertices and the foci. I see the y-coordinate is the same in all of them. So they're all going to have the same y. So it's going to look kind of like a horizontal line, right? They're all in line like this. Okay? So I'm going to do just kind of a rough sketch of where these points might be. So if this is 19,1 and -5,1, I know the center is right between there. And my foci are within those curves, somewhere there. Okay, and then the center here, I know it's in line with all of these, so the y-coordinate is going to be 1. And the x-coordinate would be directly in between these two. So between -5 and 19, I add and divide by 2, so I get 14/2, which is 7. That's my center, and that makes sense looking at the foci, because I see, oh, from 7 on the x, I go to the right 4√2. And I stay at 1 here, and then from 7 on the x, I go to the left 4√2. So from 7, I go to the right 4√10, and from 7, I go to the left 4√10. So that 4√10 is exactly my C value. Okay. So that is 4√10 for C. I could also find A, right? This is the horizontal distance from the center to one of the vertices. So A here is going to equal the distance between those. I'm looking at -5 and 7 to get from one to the other. That's 12 units. Okay, so I have A here, I have the center, but I don't have B. So I'm going to use A and C to solve for B. That gives me A squared is 144 plus B squared equals C squared. Again, for the square root, I need to bring the square into each of those terms. So I get 16 times 10. So I get 160, and then subtracting 144 gives me 16. So I can write my final equation. This time I have x first because the hyperbola is on the left and right, so I know x is the major axis. Okay, and then my h and k come from the center. Right, this here comes from the center. 144 is a squared and 16 is b squared. Okay, if you want to go ahead and try numbers 5 and 6, do that, and I would pause here and then I'll show you what I did for these. So for number 5, you want to plot these points. It's going to look something like this. Again, you want to make that general T shape. It doesn't have to be exact. You know, the center is right here. It has to have the same x as the vertices and the same y as the endpoints, so you get this. Okay, finding the distance between there, the vertical distance b must be 7, and the horizontal distance a is 11. Okay, those are the vertices, so this is where my hyperbola would be. So I'm going to put y first, so I get y plus 7 squared over b squared, which is 49, minus x plus 3 squared over a squared, which is 121, equals 1. Okay, and then for number 6, I see that all of these points have -7, -9, and then they have a square root thing after. But that -7, -9 is kind of my base point, right? And then from there I go up or down 5 root 3 for the vertices, and then I go up or down 5 root 5 for the foci. So I'm going to kind of plot it that way. I'm going to start with -7, -9 here. And then I'm going to think, okay, if I go up and down, I'm going to have my vertices. And I went up and down by this extra 5 root 3 here. Up 5 root 3, down 5 root 3. Okay? And then I'm thinking, okay, the foci I know have got to be, that value is going to be b. And then I know the foci are inside of the curve. And in order to get them from -7, -9, I went up 5 root 5 and I went down 5 root 5. So my c value here is just going to be 5 root 5 from the center to focus point. Okay, now I have the center and I have b, but I need a still, so I'll use this equation to solve for a. And squaring these, b is 5 root 3, so when I square this, I square the 5 first, then I square the root 3 and multiply them together, so I get 25 times 3. And then same thing here. C is 5 root 5, so I do 5 squared and then root 5 squared, which would be 25 times 5, which is this. Okay, so that gives me a squared plus 75 equals 125. Subtracting 75, I get a squared equals 50. Now I have a squared, I have my b squared value is this, and I have the center. Using all that, I can create my equation. I get y plus 9 squared, and then x plus 7 squared using the center point here. Right? This is -7 is h, and -9 is k. Okay, and that's going to always be equal to 1, and then my b squared I know is this, so 75, and a squared I just solved for that is 50, so that's my equation there. Alright, and that's it for today's lesson. I will see you guys tomorrow. Thank you.